there. My name is Nick Cashiola. I'm a sophomore computer engineering major at Texas A&M, and I work for AEXA Aerospace, a company that's developing mixed reality software. So today we're going to be looking at mixed reality and spaceflight. So what exactly is mixed reality? Mixed reality is the merging of real and virtual worlds to produce altered fields of view for the user, where both physical and digital objects coexist and interact in real time. So this means that when you look, it's different from virtual reality in that virtual reality creates the entire environment around you. However, mixed reality uses the physical environment around you coupled with digital imagery. The digital objects mentioned in the definition of mixed reality are often referred to as holograms. A hologram is defined to be a three-dimensional image formed by the interference of light beams from a laser or other coherent light sources. So when you're looking out in your mixed reality field, holograms will be placed around you in your physical environment as well. This way you can see the chair in front of you, but also the hologram to its left or right. Medium through which we view mixed reality is some sort of hardware worn on the head that can resemble either glasses or some sort of headset. Currently, the Microsoft HoloLens is the leader in mixed reality headset. It's quite cumbersome, weighing almost 13 ounces, so it's still quite heavy and it is still at a prototype level stage. The HoloLens uses spatial sound, gaze tracking, gesture input, and voice support to allow the user to interact with the holograms around them. As the user moves their head, the holographic cursor moves. As the user makes certain gestures, the HoloLens responds by making the corresponding action. So when you put the HoloLens on, if you ever do, you'll notice that there's a field of view in front of you. So there is a white cursor that will be placed in the middle of this field of view. That will move around as your head moves around. So the HoloLens uses the spatial tracking of the way your head moves and the positioning of yourself in the room to determine where the cursor will be placed in your field of view. It's very interesting how they do this, but it's also proprietary knowledge, and Microsoft does not share how they do this. The other way that they use gesture input is the same way. When your hand is inside the field of view of the HoloLens, the HoloLens registers your hand as some sort of object. And so when your hand makes certain gestures or inputs, the HoloLens registers this just as your computer would register a click on the mouse, a touch of the keyboard, or powering off even. It also uses voice commands. The HoloLens has a built-in microphone that can listen to the user's voice commands. So there's various voice commands like remove, open, adjust, that kind of thing. So how will the HoloLens affect the aerospace industry specifically? The journey to Mars is one of the leading factors in mixed reality development. How can we utilize the holograms of the MR world to make getting to Mars easier or safer or more efficient? So the three most prevalent solutions in the aerospace field right now are a heads-up display, a training tool, and as a problem-solving tool. So the HoloLens will be used in place of current technology as a solution to three maybe spatial issues that NASA has right now. A heads-up display, or HUD as it is commonly referred to, is a display of instrumental readings in a vehicle that can be seen in the field of view of the user. The speedometer and your fuel level on your car is part of the heads-up display for your car. In its most simple function, the HoloLens, or whatever future mixed reality headset, will be used as a way to display information to the crew in an efficient manner. The use of this digital display in the form of the Microsoft HoloLens would significantly reduce the need for hardware space. Hardware space on a spacecraft is heavy and expensive. It costs a lot of money for us to get things out of orbit if it weighs a lot. So if we could use the Microsoft HoloLens to create digital heads-up display instead of using physical screens or computers, it would save NASA a lot of money in space. This money in space could then be transferred to using towards water storage, food, battery, power, anything else. So it actually is very important for us to figure out ways to make the capsule the most efficient that we possibly can. The HoloLens is only about this big, but the hardware needed to run a computer is much larger. So it obviously leads to improvements in the efficiency of the capsule. Here's a picture of an astronaut using a HoloLens in a IVA workstation on the NEMO mission. So IVA stands for intravehicular activity. So the IVA workstation is an analog to the EVA activity that's going on outside. So NEMO is an underwater research base off the Florida Keys that NASA uses as an analog to spaceflight. So here this astronaut is using the HoloLens as an IVA workstation tool for him to be able to view things that maybe he wouldn't be able to view with just those limited amount of computer screens. This heads-up display that the HoloLens is utilized for here gives the IVA work member real-time information based on the EVA as to what's going on, such as temperature readings, dial readings, something like that. It is also used to view camera feeds for the EVA, so it allows the astronaut to manipulate their workstation in a digital environment as well as having physical screens in front of them. Here's a video of what it looks like for the astronauts at the IVA workstation. The holograms can sometimes overlap on each other because they are placed as objects in the real field. So some holograms are placed in front of some holograms and other holograms are placed behind other holograms. So you can see there that the crew member was using it as a as a video viewing tool. So he was viewing one of the helmet cams on one of the dive suits that they use underwater there. He also had what they use as Playbook open, which is their mission planning tool. So he was viewing what they were planning on doing for that EVA real time in a digital environment while he was also viewing the video headset feed from the swimsuit. So there's a lot of different ways that the crew member can organize their digital displays. That way it makes it more personal instead of fixed and hard like the way that these physical workstations are set up. So another great function of the HoloLens is the ability to live stream the user's field of view, as you just saw in that video. So the HoloLens is accessible via its IP. So every HoloLens is connected to some sort of network or Wi-Fi to be used to its full capability. And you can go to this gateway via the HoloLens IPv4 IP, and you can live stream the user's field of view. And so this creates a lot of opportunity for us. And so developers can access this field of view not indirectly. They don't have to go straight through the home page of this developer portal. They can rather go directly through the IP and pull that video. And so this allows them to integrate this live streaming capability into their apps. And so this allows someone who is not using the HoloLens to see what the HoloLens user is looking at, which is a very valuable tool. And so this allows them to provide off-site or off-vehicle analysis of what the user is doing. This applies to mock-up work as well. So the instructor can remotely monitor what the trainee is doing and give them real-time instructions on how to operate a panel, install a device, or fix a mechanical issue. And so one of the things that goes on right now when you go into mock-up training is that you'll have an instructor right beside you pointing at things that you're supposed to be interacting with or learning how to use. Instead, they could put on the HoloLens and have an off-site instructor be walking the trainee through in a more spatially sound environment. And so that way, it's more like it's going to be on the International Space Station, which is called in context, which is very important to training at NASA. And so the training tool would also theoretically allow us to view the physical holograms alongside physical mock-ups. And so the conjunction of the holograms and the physical mock-ups could allow for more in-depth, in-contextual training, allowing for NASA to further train their astronauts more efficiently in the way that they learn how to do the things they need to do on the International Space Station or wherever they're going to need to go. They've actually done some studies, and so when people use some sort of virtual reality or mixed reality headset to supplement their training using holograms, because it is more in context, they actually have a higher retention rate. And so reading the document in front of you has about a 5% retention rate, but using a mixed reality or virtual reality headset to show you what you need to be doing has a retention rate of almost 83%. The third and final tool or solution that the HoloLens could possibly provide NASA is as a problem-solving tool. So easily, it's the most futuristic of the possible solutions that the HoloLens provides. The reason why it's probably the most futuristic is that the HoloLens in its current capacity is very limited in its hardware. The processor cannot handle high levels of load like a regular computer can. It's just the nature of the beast. It is a small mobile device, similar to your phone. Your phone couldn't handle the level of games that your $2,000 rig at home could. And so, theoretically, the HoloLens could use its ability to see the user's field of view and automatically, and using its internal processor, analyze the surroundings and give the user real-time instruction or guidance on how to solve an issue. So imagine this. An AI is built into the headset that can let the astronauts going to Mars solve any emergency or technical issue right away. The delay between Mars and Earth communication can be up to 13 minutes or more, and so if you've read The Martian, you can see why that would be an issue. If one of the astronauts on Mars has an issue with something that's going on, they would have to message Earth, wait for them to figure out what to do, and then get a response. This can be a long wait period for the astronauts, and if it's urgent, that might be like life-saving or cost the astronauts their lives. So if they could figure out a way to allow the astronauts to real-time diagnose problems or troubleshoot issues with technology, it would allow the astronauts to be more safe and more efficient. That way they're not wasting power communicating or not wasting time. And so the AI process of this would allow the astronaut, it would procedurally go through the environment that the astronauts are viewing and allow them to, allow the AI to come up with ideas for the astronauts to solve the issues at hand. So with mixed reality, the possibilities really are endless. The three solutions that have been discussed in this presentation are merely just the tip of the iceberg. Beyond aerospace applications, on Mars there are geological, logistical, medical, and many more problems that a mixed reality headset could solve or assist with. I mean, at the most basic one, the geological, I could see the HoloLens also being used as a mining tool for them to collect samples or analysis of different kinds of rocks or searching for water or life or anything like that. These problems that need solutions have only manpower standing their way. They only need people to come at these problems from different perspectives and attack them. If you want to get involved, all it takes is some creativity, hard work, and technical knowledge. So to get that technical knowledge, the HoloLens currently supports Unity, which is a game engine, so this is more computer science code area. If you're interested in getting involved with mixed reality development, all it takes is to download Unity from their website and start on their tutorials. So when you download Unity, the first thing you'll see when you open the app for the first time is on the left, it'll say tutorials. And I think the first tutorial is called the Rolo Ball, and I have done that one myself. It's self-paced and allows the students to learn exactly what they need to be able to work on their projects. And there's many more different kinds of tutorials for literally anything that you could think of in the Unity space. Microsoft also has their own developer support, which can be found at www.microsoft.com/en-us/HoloLens/developers. This website has discussion forums as well as learning resources for you to get started. Because this is a new technology, a lot of people don't know the answers to every issue that comes up with the HoloLens. So they have discussion forums where different developers can interact with each other, bounce ideas off of each other. It's a very, very cool creative space, as well as their own Mixed Reality Academy, which can teach you some of the ins and outs and technical know-how to be able to develop in the mixed reality world. And Microsoft, in its own right, separate from this website, also has their own C#, Python, and other coding tutorials that allow you to use Unity to its fullest extent. So thank you very much.